class. சரி, ஆசைப்பட்ட பொண்ணையே உனக்கு கல்யாணம் பண்ணி வைக்க சொல்லி கேட்டுருவோம்டா. சீக்கிரம் வேலைக்கு போ. அதுதானே சொல்றாங்க. வேலைக்கு போயிடு, உடனே உனக்கு கல்யாணம் 10 நாள்ல. அவங்க பண்ணி வைக்கிறாங்களோ இல்லையோ, நான் உனக்கு பண்ணி வைக்கிறேன் வாடா.
Okay, we'll start the session. Good evening, everyone. This is Saravanan, PhD scholar and Prime Minister Research Fellow of National Institute of Technology, Tiruchirappalli. So, as a part of PMRF, I have to take 2 hours of NPTEL TA-ship. So, in this regards, I have chosen Municipal Solid Waste Management course that was originally taken by Dr. Ajay Kalamdar sir from IIT Guwahati. And so, we are in a 9th week of this problem solving session. So this 2 hours of problem solving session will go in a phase. Like the first phase will be I'm going to teach the same lecture material what sir has taught in the videos, and then in the second phase we are going to solve the old assignment problems. So I'll move on to the lecture material. Yeah. So, as we discussed, there are 6 functional elements of municipal solid waste, from waste generation, collection, that is storage and handling, then collection, then secondary collection, transfer and transport, processing and storage, then disposal. So these are the basic functional elements of municipal solid waste management. So in the first week, we have discussed about what is solid waste and what are the types of solid waste and how to uh, uh, differentiate the solid waste based on its source of generation. And then we have discussed about how to handle the waste and how to store the waste at the site of generation, and then how to collect the waste, that is called primary collection. And then we have discussed about the secondary collection, that is from the transfer station to the disposal point, and then how to transport the solid waste, the transfer vehicles, and then collection mechanism analysis we have done, and then processing and transformation. In the processing we have discussed about the physical processing techniques, and in the transformation we have discussed about the biological transformation, that is in aerobic we have discussed about windrow, and anaerobic we have discussed about anaerobic digestion and different biogas generation techniques we have discussed. And today we came to the final functional element of municipal solid waste, that is called disposal. So disposal, as we all know, in past 2 centuries we are simply discarding the municipal solid waste in the open dump sites, open areas, that is called dump sites. So there is a difference between landfill and a dump site. So landfill is a scientific method of disposal of municipal solid waste in a contained system without affecting the environment or to the atmosphere. But dump site is the unscientific way of disposal of municipal solid waste, which may create threat to the human health as well as to the ecosystem. So that's what we are going to discuss, how to manage the solid waste at the disposal point. So broadly we are going to discuss about the landfills. Okay, yeah. So landfills are suitable only for the waste that are not suitable for processing and transformation. That is the waste that is only having inert content, and the industrial hazardous waste, or some of the waste containing only ash, which is having no use. If you are thinking about a paper, first you have to think about reuse, how to first reduce. You know about 6R principles. So in the first R it will be reduce. How can I if I am taking about an example, like I'm going to print a sheet. So instead of printing, if I am going to read the same as a PDF format, so I am reducing the waste to be generated. So that is called reduce. So if I want mandatory to print, now and all, you can see in the mail itself, if you really want to print, you can print. Otherwise you can save some of the papers and save trees, like that. Some of the environmental codes you can see attached with the mail itself. So I am reducing some of the solid waste that is going to be generated. Then if it is generated, I want to print the paper, then I am reducing. So instead of printing in two sides, I am printing in one side. Sorry, instead of printing two pages, I am two papers, I am printing in one paper on both the sides. That is called reduce. So instead of wasting two papers, I am wasting only one paper. That is called reduce. Then reuse. After printing that paper, how can I reuse the same paper for some other purposes? Like I can use the same paper. Yeah. So, okay. So we are discussing about the disposal of municipal solid waste. So I am giving an example related to printing of paper. If I am trying to print a paper, so how to reduce the waste? Instead of printing, I am going to read the same content in a PDF format. So if it is necessary, I am printing in a paper. But instead of printing in two papers, I am printing in one paper both the sides. That is called reduce. So if I have printed in both the sides, how can I reuse the same paper for some other purposes? Like the extra pages I can use for some other rough writings, like that. So that is called a reuse purpose. And then recycle. So the waste paper can be recycled to produce some other cardboard materials mixed with some other pulp, and we can produce some cardboards. That is called recycle. And then recover. So what are the things that can be recovered? So material side we have already recovered. So what are the energy embedded in the waste that I am trying to recover? That is called recovery. So after if nothing is possible, like I can't reuse, reduce, I can't reuse, I can't reduce, reuse, and then recycle, then after I can't recover, then I will think about the disposal. Only the ash that is left over, that I am going to dispose. So the disposal is the final hierarchy of municipal solid waste management. Okay. So in this lecture, the ninth week, we are going to discuss about the disposal of municipal solid waste, that is broadly the landfills. Okay. So first we are going to discuss about what are the types of landfill and how to select the site for the landfill. So initially we are going to discuss about the history of solid waste management in India, how they have dealt with this municipal solid waste in the past years. So earlier days, the solid waste was dumped in the unoccupied land stretches. That's what I have mentioned about the dump sites. So dump sites are different from landfills. Landfills is a scientific containment of municipal solid waste, but dump site is a open disposal of solid waste in a land without any proper containment, so which may affect the human health and the environment. So dumping in unoccupied land stretches, or they may burn the waste at the generator sites itself, at the backyard or in a open area. They will simply burn the solid waste. That are the two options they have followed in the earlier days. But in 1994, after the Surat plague, so you know about the Surat plague case in 1994. Due to the huge flood, the whole sewer line was clogged, and it resulted in the growth of rodents, and it caused plague. So that is a plague epidemic. Like we had a pandemic like COVID, like that plague epidemic was outbreak was there in Surat in 1994. After that, Almitra Patel filed a PAL in 1996 to the Supreme Court, and then the Berman Committee was formed. It was a subsequent formation of Berman Committee after the case was filed. So with that committee recommendation by the to the Ministry of Environment and Forest, they introduced a special act for the municipal solid waste in 2000. That was now we are following Municipal Solid Waste Management Rule that was amended in 2016. The first rule was came in 2000. That's the Municipal Solid Waste Management and Handling Rules 2000. It was proposed by Ministry of Environment and Forest in Government of India. Okay, so this is the broad history of solid waste management rules in 2016. Why they have worried about the open dump sites? Because open dump sites, open dumping of solid waste that is without any protection to the environment will the waste will be exposed to the vectors and scavengers. So any animals or rodents can come and take the eat this thrown away materials, and they may spread some of the diseases like mosquitoes will be there, and then some of the rodents and domestic cattle will be coming, and then you can see some of the cows having lots of plastic inside their guts, like that many threat to the human health as well as to the animals, domestic animals. And then open dumping has huge environmental and health concerns, like it may catch fire easily because there are mostly plastic material will be there. So after some point of ignition, it attains the ignition temperature, it will easily catch fire. And also it has a methane gas because of the anaerobic digestion, because it's not aerated system, it's a dumping of solid waste, so it will be in anaerobic condition. So once the organic material in the waste got degraded in the anaerobic condition, it will produce methane gas. So methane gas is easily flammable, readily flammable, so it will catch fire easily. And also most of the material in the dump sites are combustible materials. So gas is also there, combustible material is also there, atmospheric air is there. So once it catches fire, it may spread like anything. Recently also in March we had a outbreak in Kerala Brahmapuram landfill fire. So that got a huge attention nationwide. So that case we are going to discuss in the upcoming weeks also. And then open dump sites are breeding grounds for most of the disease carrying vectors like mosquitoes and rodents and all are breeding in this dump sites only. And many other problems like it may contaminate the surface water and groundwater, because whatever the leachate, you know what is called a leachate. Leachate is the contaminated liquid squeezes out from the solid waste in the dump sites. Whatever in the dump sites or in the landfills, due to the percolation of rainwater, it may squeeze out with lots of organic matter and hazardous heavy metal. The water will be squeezed out from the solid waste. That's called leachate. So this leachate may percolate into the groundwater, or it may go with the runoff, and it will affect the surface water bodies also. And also the soil, what are the soil present below ground will also get affected. So it again, what are the component present in the leachate? If you see, lots of COD, lots of heavy metals and nutrients that is present in the leachate, which will be the threat to the water resources. Like groundwater is a precious resource for fresh water, and so this and all will be contaminated. And open dumping decreases the quality of life and to the nearby residents and local community. So if a dump site is present in a place, the site nearby will not be having any value, and the people will the residents nearby, they will also vacate to some other places. So the value and the quality of life will be reducing nearby this type of dump sites and landfill areas. So to control the two main pollutants in the landfills are, one is landfill gas and another one is landfill leachate. So to control these two main pollutants from the dump site, we are going to a scientific method called landfilling. So if you are simply dumping the waste in an open area, it will create leachate, it will create landfill gas, that is methane gas. So how to control these two main pollutant? We are going to think about a scientific method that is called landfill. So landfill is a physical facility used for the disposal of residual solid waste. That's the important word you have to note down. Residual solid waste. Not all the municipal solid waste. Landfill is not for organic waste. Landfill is not for recyclable waste. So after segregating all the organic waste to the compost plant or anaerobic digestion and all the combustibles and recyclables to the material recovery facility, that's what we have discussed in the transference transport. Then after segregating everything, whatever the leftover hazardous or residues, that only will reach the landfill. Okay, it's a scientific physical facility used for the disposal of residual solid waste in the surface of the earth. Okay, so landfilling includes monitoring of incoming waste stream, placement and compaction of the waste, and installation of landfill environmental monitoring and control facility. These are all facilities in the landfill we are going to discuss in the upcoming slides. Okay, so majorly there are two types of landfill. One is sanitary landfill, another one is secured landfill. This is very important. Sanitary landfill is for municipal solid waste. That's an engineered facility for the disposal of municipal solid waste. But secured landfill is for the disposal of hazardous waste. So, these two you have to differentiate. One is hazardous waste, another one is municipal solid waste. So the residue from the municipal solid waste will reach the sanitary landfill. So that there is no much precaution or monitoring required for monitoring is required, but there is no much monitoring is required for sanitary landfill. But for hazardous waste, the design should be different. That's called a secured landfill because it's more hazardous. We need to restrict the leachate in a contained way. So that is called a secured landfill. Second landfill for hazardous waste. Industrial waste or industrial hazardous waste, we have to use a secured landfill. Some of the pictures of the landfill construction you can see here. Yeah. Then every design will have a lifespan. So landfill design life is comprises of three parts. One is active period, then closure period, then post closure period. So active period will be around 20 to 25 years. If I am having 40 acres or 50 acres of land, so to a maximum permissible height of 20 meters, how many days I can use the area for the storage of or the disposal of municipal solid waste. So in Trichy, we are having a dump site in Ariyamangalam that is having an area of 47.7 acres. So to the height, maximum permissible height of 20 meter. So if you multiply this area with the height, you will get how much volume you can accommodate. So we know the waste generated in a day. Then we can calculate how much days the landfill can be used for storing the future solid waste. So it may be around next 50 years or next 20 years. So it will accommodate this municipal solid waste from Tiruchirappalli. So that's the calculation we can, simple calculation we can do. So our active period is until closure, how much days it will accommodate the solid waste. That's called active period. So 20 to 25 years depending on the availability of land area. So once the land area and the height is over, we have to close the landfill and we have to choose some other area for landfill construction. Okay, that's called the active period. Then closure and the post closure period will be for the sanitary landfill. It should be monitored properly and maintained. So 15 years is called a post closure period, and after the active period, that is 20 to 25 years, next 15 years we have to monitor. Then only we have to allow human habitation in the landfill area. So once it was like a hill, after closure, after 20 to 25 years active period, it will be closed like a hill with a proper cover and all. But humans, you should not convert this into a park or some other recreational place. It should be monitored for next 15 years for any contamination, gas production or leachate. After full stabilization, after next 15 years, 25 plus 15 years, it will be around 40 years. We can have some human habitation, or we can have some recreational activity like park or some other community areas we can create. Okay, these are the two main period we have to note down. One is active period, another one is closure and post closure period. Okay, so if you see about the status of municipal solid waste management in India, we have 29 states. This is around 2016's data. 29 states, out of 29 states, 18 states are having house to house collection. That is door to door collection, we will say. Out of 29 states, 5 states are following segregated waste collection system. So in the house itself, at the source itself, they are segregating the solid waste and then they are collecting. So in the 5 states, we are following source segregation system. So number of unsanitary landfills in India, it's around 1285. We have totally 1380 landfills in India. Around that 95 are sanitary landfill and another other 1285 are unsanitary landfill, that is called dump sites. Okay, so you have to think about the huge environmental threat and the human health threat due to this much unsanitary landfills. Okay, so this is from CPCB report 2016. So what are the waste that can be accepted to the landfill? That's what I have mentioned. There should not be any organic waste. There should not be any recyclable waste. There should not be any combustible waste. So if the waste is having some value, it should not reach the landfill. So all the waste should be segregated properly. It should have some value. So it will be treated with a proper treatment technology. Only the waste which is not having any value should reach the landfill. What are this type of waste which is not having any value? That's what I have mentioned as residual municipal solid waste. So what are this type of residual municipal solid waste? You can see first one is non-biodegradable and inert waste by nature or through pre-treatment. So what are the ash, what we are saying, and non-biodegradable waste can reach the landfills. And then commingled waste, mixed waste which is not found suitable for waste processing. So once the waste source segregation is not following, all the waste are mixed, then I can't separate the waste. So commingled waste, that's called a mixed waste, that can reach the landfill, which cannot find any suitable processing technology. Nowadays, we have some options for treatment of this type of mixed solid waste also. So if there is no other option for treatment of mixed waste, that can reach the landfills. Then pre-processing and post-processing rejects from the waste processing sites. So if from the compost yard or from the MRF facility, what are the waste rejects we are getting? That's called a pre-processing and post-processing rejects that can reach the landfills. And then finally, non-hazardous waste. Not being processed or recycled. The type of non-hazardous waste we can have, but hazardous waste should reach the secured landfills, not the sanitary landfills. So in the sanitary landfills, non-biodegradable and inert waste, commingled waste, which is not having any value, and then reject from processing sites, and then non-hazardous waste, which cannot be recycled and processed. So these are the waste categories suitable for sanitary landfills. Okay. And then we have another type of landfill separately for construction and demolition waste. So as you all know about C&D waste category. So we have lots of solid waste management rule like solid waste management rule 2016, battery waste management rule recently we had 2023, plastic waste management rule, e-waste management rule, and then construction and demolition waste management rule, biomedical waste management rule. Like that, we have lots of solid waste management rule and their categories, out of which construction and demolition waste majorly plays a role because there is a huge quantity of C&D wastes are producing nowadays because of construction and demolition activities. So how to dispose that waste, because it's mostly of inert and mixed categories and more hazardous also because of the presence of electrical wires, paints, hazardous things that is present in the habitation like tiles, and then lots of paints and all will be mixed after demolition. So it should be treated managed properly in a separate landfill or a cell. It should not be mixed with the municipal solid waste. Why it's stored in a separate place? Because it can be mined in future and it can be used for some other earthwork or road projects. Because this type of C&D waste found application in the this type of construction activities, again in the road construction and earthwork construction, and for low-lying area filling we can use this type of C&D waste. So it should be separately filled in a cell, and it can be mined in the future for use in the earthworks and road projects. And then C&D waste can also be used as a daily cover or for the road construction. So every landfill, that's what we are going to discuss in the upcoming slide. So every cell or every day waste will be covered with the daily cover. So this C&D waste can also be used as a daily cover instead of soil. Okay. This is what we are going to discuss. The component of landfills. What are the different components of landfill? You can see this is a landfill. So everyday waste, this is the ground. Everyday waste will reach the landfill. So it will be disposed in one designated area that is called a cell. So in a day, if I am getting 1000 tons of waste, so that will be stored here, and then it will be covered with a daily cover, a layer of soil, and then the next day it will be poured in the next area, that is compacted, and then again we have to fill with the daily cover. Then at the top we can fill the third day, fourth day, like that it will go for the next 25 years. It will be sealed with the final cover. So that's what the final cell and then final cover system. And then bottom in the ground also we need a landfill liner system to protect the groundwater and the below ground soil from the leachate migration. And what are the height of the cell? That is called lift. And then the cell width is called this is called cell width, the area wise, and then height wise it is called lift. This is called the final lift and the final cell. Okay, and we have to maintain a proper slope because we are going to construct this landfill for next 20 meters height. So it should not be slided. So landslide may also happen in the landfills also. You have seen near nowadays Wayanadu landfills landslides we had seen in the last month. So we have lost lots of people also in that Wayanadu landslide. Like that, landslides may happen in the landfills also. So we have to maintain a proper slope. Otherwise, this type of landfill may slide and it will contaminate the nearby area. And we will have a lots of losses due to this landslides. So we have to maintain proper slope, like 3:1 typically we have to maintain the slope. So first component is cell. Cell is one operating period. Usually 1 day's waste will be deposited with a daily cover, that is called a cell. Okay, daily cover is the 6 to 12 inch soil cover or any alternate material we can keep. That's what I have mentioned about C&D waste. The C&D waste, whatever we are collected, that can be used as a daily cover in the landfill itself. Okay, so why we need a daily cover? Because it controls the blowing of waste material and entry of water, prevent disease vector from entering into the landfills. If we are after compacting the waste, one day waste, we have to, if we are not giving the cell, it may bulge, and whatever the rainfall happening in that 20 years will reach the groundwater. So we have to protect the waste from the rainwater. So we need to have a proper cell. Otherwise, the rodent, mosquitoes, and the vectors, disease-causing vectors may enter into the solid waste, and it will create nuisance. That's why we need a daily cover. Okay. Then lift. Lift is the height of the daily cell. So complete layer of cell over the active area of the landfill. So complete layer, one layer is called that height is called a lift. Okay. Then bench or terrace. Bench or terrace is the cell width we are going to discuss. So used where the height of the landfill exceeds 50 to 75 feet. If it is exceeding, then 50 to 75 feet in the sense it will be around 30 meter, 30 sorry 25 meters it will be around. So it maintains a slope stability. For that we need to have a proper bench terrace. If you are going straight, so if it may have a landslide, so we need a bench, that is called a terrace, that without any slope we need a proper horizontal surface, that is called a bench. And it will be also suitable for drainage of water drainage system, and also for landfill gas recovery piping we can use this area. Okay. Then final lift. So every cell will have a lift, and final cell will have the final lift. That includes the final cover layer. Final cover layer will be having large thickness, and then final cover layer applied to the entire landfill surface. So daily cover will be for one cell, and then after filling all the cells, the final cover will be for the entire landfill surface area. After entering, entire landfill operation was completed. After 25 years of active period, we need to give a final cover layer, and then it will be monitored for next 15 years for leachate and gas control. Okay. Then leachate is the liquid collected at the bottom of the landfill. It's the definition. Leachate is the liquid collected at the bottom of the landfill. Why leachate is generated? Because of the rainfall, that is called precipitation, or due to anaerobic digestion of the solid waste, it may create some water. So in the reaction itself, some H2O will be formed. So that water will also be collected due to gravity. It will enter the bottom of the landfills. Okay. So next term is called landfill gas. Landfill gas is the we can also say this is as a biogas, but once it was generated from the landfill, we are saying this as landfill gas. Again, due to anaerobic digestion, we will get methane as the product. In 100% of gas, 60% will be methane, 30% will be carbon dioxide, and 5% will be some trace gases. So this type of mixture of gases will be produced from the landfill, that is called biogas or landfill gas. formed as a result of degradation of biodegradable organic matter present in the waste. So this is the main part. If we avoid organic waste entering into the landfill, there is no landfill gas generation. So we can prevent the atmosphere from biogas generation, because whatever the methane coming out, that is having more greenhouse potential. Whatever carbon dioxide, if you take as one greenhouse potential gas potential, then methane will be 24 times. So 1 mole of carbon dioxide will have 1 methane greenhouse gas potential. Then 1 mole of methane will have 24 times more what we can say harmful than compared to the carbon dioxide in terms of greenhouse potential. So this should be avoided. Methane generation should be avoided. For that, we need to avoid organic matter entering into the landfills. Okay. Then landfill liner. Landfill liner is the layer that is kept at the bottom of the landfill. Before starting landfill operation, we have to give a proper cover at the bottom, that is called the liner system. So line at the bottom area and below grade sides of the landfills, that is called the liner system. We can use compacted clay as a liner, because clay soils having a low permeability, around 10 power minus 12 centimeter per second. That much low permeability will be there for the clay soil. So once the clay soil was compacted, and then if you are starting the landfill operation, then there is no leachate migration into the groundwater. Or we can use some of the synthetic material like geomembrane, geotextiles, geonet, that are all useful for liner systems to prevent migration of leachate and the landfill gas. Okay, the same can be used as a cover system also. So I think I have discussed about all the components of landfill. So we need a proper cell, daily cover, and then final cover system, and then bottom landfill liner system, and to prevent leachate control system, and to prevent landfill gas collection, and the flaring system should be required. Hope you understood about the components of landfills. Then how to do landfilling? After designing the area we have calculated, and then height we have calculated, and then we have the design period also, and we are getting the solid waste from the city. We know all the components of the landfill. So how to do landfilling? How to design a landfill? We can say this is a design itself. So can I dig the area, or can I do the landfilling at the above ground level? So this thing is differentiated with the three principal methods. One is called the excavated cell or trench method, then area method. The third one is canyon or depression method. So these three methods are based on the availability of land area, also the condition of the land. That is the condition of the area site, we can say. So once everything is based on the I'll draw the thing. So if you have the ground area, this is the available ground you are having, ground level, and the water table level is here. This is the water table level. So I am going to dispose the solid waste here. So I can excavate the land up to here, and I can fill the solid waste. So I can have lots of volume. Above also I can fill. So solid waste. So instead of this much meter cube, I am getting some extra volume for the accommodation of solid waste. Once the water table was higher, if the area is having lots of the water table near to the ground, then I have to use only the area method. So this is called the excavation or trench method. This is called the area method. And another one is called the canyon method. Canyon method is the one when I am having mountain region or a valley region. So I can use this valley or a canyon region for filling the solid waste. So this mountain acts as a natural barrier for the leachate migration and landfill gas migration. So I can, although I need some liner system and a proper cover system. So this mountain can be, the valley or the canyon can be used as a barrier for solid waste management, disposal. Okay. So whenever the water table is lower, I can use excavation or trench method. Whenever the water table is near or higher, then I have to use the area method. Whenever I am having a mountain region, a Himalaya kind of region, I have to use canyon method for the disposal of for the landfill area, site selection. Okay, so we have to analyze the level of groundwater throughout the year, through the whole monsoon season and the dry period. Everything I have to analyze, and I have to check for the maximum level of water table. So the maximum level itself, this much means I can use both excavation or trench method. If the maximum level of water is reaching this, so I should avoid excavator or trench method. Hope you understood about principal methods. Okay, so excavator trench method, groundwater table is not near the surface. Then trenches are dig and lined with the synthetic membrane. So we have to dig the earth and we have to line with some of the geomembranes, and then the solid waste are placed in the trenches. Okay, and then soil excavated can be this is very important. Whatever the soil excavated can be used as a daily cover and also for final cover system. Okay, trenches can be around 20 to 1000 feet long, 3 to 10 feet deep, and then 5 to 15 to 50 feet wider. Like that, you can see here the trenches sizes. So if it is an area method, then it should be used in a terrain where the groundwater table is higher. Then I should not dig the area. So cover materials are hauled from different location. Instead of excavation, I have to get soil from some other area, and I can use as a daily cover and final cover. And site preparation include installation of everywhere we need installation of liner and leachate collection system. Then canyon or depression method will be for hilly regions. In hilly regions, the ravines and the dry burrow pits and the quarries, abandoned quarries, you can say. After mining, people will abandon the quarries. This abandoned quarries can be used as a landfill sites because it's having a natural barrier system. Compacted rock will be there, so we can use that as a uh, landfill site. But you should be very careful to check the fractures in the rocks. If there is any fracture in the rock, then the leachate may migrate through the fracture and it will reach the groundwater. So we need a proper liner system for the depression method also, canyon method also. We need a proper liner system. Okay. So here also cover material should be hauled from some other places. So those are the three principles of landfilling methods. Then landfill site consideration. So how to select the site as an engineer? I am going to design the landfill. What is the area? Which area I can choose for a landfilling site? So in Trichy, if you see, I'm an engineer. I'm going to design a landfill site. So I will first check haul distance. How close it's near to the generation point. So I should not choose the landfill site away from the city area. It should be again the transportation and the collection and the transportation cost constitutes about 90% of the total solid waste management cost incurred. So our main motto is to reduce the transportation cost and the collection cost. For that, the disposal point should be very near to the not very near, it should be near to the generation point. Otherwise, the haul distance will directly increase the transportation cost. Okay, then location restrictions. If there is any historical place or public places, it should be avoided. Like 20 kilometers should avoid away from the airport. Why it should be away from the airport? Because landfills may attract many birds. It may come to eat some of the leftovers in the landfills. So birds may hinder the planes movements. So for that, we need to avoid landfill site 20 kilometer away from the landfills, airports, then 200-meter away from the highways, because again it's due to the some of the plastic may fly from the landfills and it may reach the highways. So it will be again a nuisance. So it should be 200-meter away from the highway, 500-meter from the habitation, because whatever the methane gas generated will affect the human health. And then 300-meter away from the public park, because children may be there. 500-meter away from the water supply well, because the whatever the leachate that is generated may contaminate the well or the groundwater. So it should be 500-meter, at least 0.5 kilometer away from the water supply well, and then 200 meters from the pond and 100-meter away from the river. So please be remain with this numerical values. And main areas, airport, highways, habitation, like public parks and all. Then water supply system, it should be very far, and then pond and rivers. Okay. Available land area, a minimum 20 to 25 years I need this landfill to be in operation. For that, how much area I need to choose? I know the population of the city, I know the waste generation rate, I can easily multiply and get how much waste quantity that is generated. Then for next 20 years, I know how much waste is going to get generated. For that, with 20 meter of height, I know how much area required. So if I require this much of area, then I have to choose the area, site which is having the proper land area availability. Then site access. If it is very far, very close to the city, then it will have some traffic constraints. So it should have proper access. And then soil condition and topography. Soils, what the soil will be there can be used as, it should be usable for cover material. Otherwise, we have to get some soil from remote places. That will again incur some cost, operational cost in the landfills. And it should have low porosity and extensive work required to make it suitable, usable. And then climatic conditions. It should not be always rainy. Then it will create leachates. Then surface water hydrology. As I mentioned, what is the groundwater level and surface water level, existing natural drainage and runoff. Because whenever uh, if your whatever the area you have chosen is like already in a trench, then you can easily fill the solid waste. You don't need to excavate. So you will the excavation cost will be reduced. But during rainy season or monsoon season, whatever the runoff will come to you the low-lying areas. So it will reach your landfill site. So again, you need a proper system to drain the solid waste. Drain the runoff water. So if you see in the top view, this is your landfill site area. So I need a proper drainage system around the landfill area, so that whatever the runoff is coming, it will go into the drainage system. Okay, the landfill site will be protected. Although it is in low-lying area, we need to have a proper excavation around the landfill site to protect the site from the surface runoff. Then geological and hydrogeological condition that may be directly affect the leachate production and landfill gas production. And then local environmental condition and potential ultimate uses of the complete site. So after closing, what I am planning to use after 25 years and 15 years of monitoring, how I am going to use the area for the recreational activity, that also need to be considered before site selection itself. Okay, so those are the main point for site selection. First, we need to location criteria. What I have discussed in the earlier sign, location criteria need to be done. Then search for the area. Then development of a list of potential site. So in Trichy itself, I have to choose area 1, area 2, and area 3. These 3 areas are suitable based on the selection criteria. After that, I have to collect data about all the 3 sites. All the 3 sites, I have to collect the data. Then I have to do a field visit to all the sites. Then I have to give rankings. Which one is landfill site 3 may have first rank and then second rank. This ranking should have some criteria that we are going to discuss. And then preliminary environmental impact investigation. So all the project environmental related or any building construction also, nowadays we need environmental impact assessment. That is separate course you can learn from Google also. Environmental impact assessment is mandatory as per government norms in India. So for any projects, it may be a new project, it may be a extension project also, we need impact assessment. So landfill construction also, we need an environmental impact. So compared to all the 3 sites, if some first site may be nearby and cost may be low, but the environmental impact may be higher, so I have to reject the site. So environmental impact plays a major role. Then final site selection. So I have to check all the criteria, search for areas, then I have to list the potential area, data collection, field visit, I have to give a ranking, then do a preliminary environmental impact assessment, then final selection. So what are the location criteria? As we have already discussed, river should be 100 meter, pond 200 meter, and then highway should be around 500 meter, habitation 500 meters, earthquake prone zone, like from fault line and all should be from 500 meter, and then flood prone zone, it should not be. Flood prone zone, sanitary landfills are not permitted. This is very important. So whenever there is a flood prone zone, sanitary landfills are not permitted. Then water table level, it should be 2 meter from the highest water table level. Above our landfill site should be above 2 meter from the highest water table level. That highest water table level may be in the monsoon. So we have to check the meteorological condition or the geological factors throughout the year. Okay, we have to collect the lot of data. And then airport 20 kilometer. It's very important. In special case, it may be permitted based on the Civil Aviation Authority and the Air Force certification, no objection certification. We can construct within 20 kilometers. Okay. Then as per coastal regulation, wetlands, sensitive ecological fragile areas, sanitary landfills are not permitted. This is another important thing. So this is the main thing what we have discussed. Highways 500 meter, human habitat 500 meter, pond, lakes and water body 200 meter, airport 20 kilometer. After location criteria, what is the thing? We need to develop a search for area. So the area should be within the municipal boundary. After seeing all this condition, it should be within the municipal boundary. And then the extent of search area usually governed by the economics. As I mentioned, transportation cost is incurred. So area should be within the boundary to reduce the transportation cost. After selection of site, we need to list all the potential sites. Identify while mapping land. If it is a land scare area, degraded sites, abundant quarries if anything there, and then old waste dump site if it is there. So we have to select from this type of things also we can choose. Okay, so rough guidance is if the waste quantity is less than 1 million tons per design life, then we require a land area of 15 to 20 hectares. So based on the quantity of waste and throughout the design life, the area can be calculated, or you can manually calculate based on the population of the city and the waste generation rate. Okay, so based on that we can have the area requirement. So we can list the potential landfill sites. So next one is data collection. So unsuitable areas are rejected based on the data, following data, like topography map, soil map. We need land use plans, water use plan, flood plains, geological maps, groundwater map, aerial photographs, rainfall data, windrows maps, because wind may also play a major role. So windrow maps are required. Seismic data, as I mentioned, fault area should not be, fault line should not be there in 500 meters within 500 meter from the landfill site. And then road map we need because 500 meter away from the highways. So this is all data we need to collect for the potential areas. Then field visit. Field visit is to check the land availability, and then a flat area or a trench we have to check, and then connection to the highway to check the transportation facility. Flooding during monsoons we have to check in person, and then land use and the soil type. Crossing of electrical line is again important because whenever we are digging or leachate migration, it should avoid crossing of electrical lines and actual settlement pattern, because after this much of heavy load, because 1000 tons of solid waste per day means after by 20-25 years how much quantity of solid waste, so it will create settlement of the landfill. So actual settlement pattern we have to check for the landfill site chosen. Then selection of best ranked site. So this is based on site selectivity index. So it's very important, site selectivity index. So this is the index based on the guidelines given by the CPCB, which will be used to select the most appropriate site. Okay, so the ranking is based on the defined criteria what we have discussed earlier for the primary impact, preliminary impact assessment. Then we have to do preliminary impact assessment for the selected 2-3 sites. We have to do, and the impact of the sanitary land will be assessed according to the national rules and local conditions. So we have a proper environmental impact assessment act and rules. So based on that we can identify the impacts. Then final site selection based on the best ranked alternatives. So environmental impact, social acceptance, land availability. So sometimes the environmental impact may be good, but the people around the site will not allow you to construct the landfill. So social acceptance should be required, or else some behavioral change we need to. It's again like a NIMBY syndrome, not in my backyard. People won't allow to do composting in their backyard. People don't allow to construct an anaerobic digester in their backyard. Like that, no people or no community will allow to construct the landfill site in their area, in their premises. So social acceptance should be very important. Otherwise, it will create some issues. And then land availability, transportation cost, and then sanitary landfilling cost. All the cost incurred. These three things are very important: economic, social, environment. So these three are the pillars of sustainability. So this is again related to sustainability. So after seeing environment is good, social is good, but the cost is very high, there is again a problem. So cost should be also be low, environment impact should be low, social acceptance should be high. Then the project is a sustainable project. Okay. So this again you have to think about. Then landfill site preparation. So after selecting the site, by this huge exercise, we are selecting the final site suitable for landfill operation. Then landfill site preparation we have to do, like drainage away from the landfill, excavation, placement of monitoring equipment like groundwater quality, air quality monitoring, and then leachate. Leachate is groundwater quality monitoring, and then landfill gas is air quality monitoring. For the next 20 to 25 years, we have to monitor during active period and 15 years of monitoring period also. Okay, this is all about site selection and components of landfill. Now we are going to discuss about leachate collection and treatment. In the next week, we are going to discuss about the landfill gas treatment. So today it's about leachate collection and treatment. So what I have mentioned about two problems of landfill, one is leachate, another one is landfill gas. Okay, landfill gas is due to anaerobic digestion. It may break down the organic matter and it will release carbon dioxide and methane. Methane constitutes about 60% and carbon dioxide constitutes about 30% in the landfill gas. It's an approximate value. And then methane is having a greenhouse potential of 28 times more potent than the carbon dioxide. So it's having 28 times more impact than the carbon dioxide. So you can think if 1 mole of methane itself is very harmful. Then second problem is leachate. So leachate is a liquid that forms when landfill water waste breakdown. That is one type of leachate formation. Like through the degradation, it may create some H2O that is again coming out through the waste. That is a leachate. And then rainwater entered into the landfill. That is another important thing. So whenever the rainwater is percolated or a precipitation is percolated, that will create some runoff inside the landfill. That is called leachate. So rainwater is the greatest contributor to the leachate. Common chemical found in the leachate are carbon dioxide, organic acids, alcohols, aldehydes, and more. So these are the chemicals found in the leachate. So it's very harmful. Like heavy metals will be there. More. So this leachate characteristics vary with the type of waste or age of the waste. In the initial period, like after 5 years or during the first 5 years, the leachate quality will be very having more COD. Then aged landfill, like 20 years, 30 years landfill will have less COD in the leachate. So based on the leachate quality, we can identify the age of the landfills. Okay, these are the component like phenols, toluene, aldehydes, ammonia, and this type of toxins may be the components of the leachate. Yeah. So these are the reactions occurring in the land. These are the reactions occurring in the landfill for the production of leachate and the landfill gas. So first one is the, as I mentioned, it's an anaerobic degradation process. So we first will be hydrolysis, fermentation. So based on that, acetate and then methane will be produced. It's called methane, and then finally H2O may be produced. That is the leachate. And then due to percolation of rainwater also, we will have some leachate. Okay, how the landfill gas and leachate will be formed during different phases. So for, if you see around this is the days, you can see 0th day, 200 day, 400 days, 600 days. If you see, first will be oxygen, whatever the oxygen present will be reduced because it's a closed environment. All the oxygen will be utilized first. Then methane production will start, carbon dioxide production will start. It will be, and then nitrogen present in the waste will get reduced, and then COD will be higher during the phase 3. We have divided into 5 phases in the landfill itself. COD will start increasing and it will attain a saturation and it will again decrease. Like the total volatile acids, TVAs, total volatile acid will also increase. H2 will increase and reduce. Gas production after COD reduction, gas production will start. So it will start and it will reduce. Okay. So these are the landfill gas, that is methane and CO2, and then total volatile acid. What do we say? leachate will also be generated. So if you check pH at the different phases of landfill during TVA accumulation, the pH will be very less, and then final phase pH will be around neutral, like 7 to 8 it will be there. So these are 5 phases of landfill, gas, and leachate. Okay. So leachate quality depends on age of the landfill. As I mentioned, fresh waste will have some leachate quality, and then aged landfill leachate will be having different quality. And then type of waste, that is composition of the waste. So whenever you are having lots of organics present in the solid waste, then the leachate will have some higher COD. If the landfill is having only plastic and textiles and rubber inert waste, then the leachate will have less organics present in the less that's what we call BOD and COD. And then environmental condition, if the rainfall is less, the quantity of leachate will be lower. And the factors affecting the generation of leachate, as I mentioned, infiltration of the groundwater, infiltration of leachate into the ground, rainfall, and then decomposed waste will produce some water. Okay. Then this is the schematic scheme of how leachate is generated. You can use these values for the calculation of how much quantity of leachate generated. After precipitation, that is called P, evapotranspiration will happen. So once the rainwater reaches the land, evaporation and transpiration will happen. That is called evapotranspiration. That is E. And then whatever the water that may percolate or infiltrate, that is called C. And then moisture content of the waste may have some own moisture content. So that is called S. And then leachate flowing will be L, you can say. And then surface runoff, all the water that won't percolate into the landfill. So some may percolate and 90% may run off. So that is called the R. Okay. And the run on will be the runoff, and run on will be there if it is a low lying area. Okay. So leachate quantity may be due to may be affected by refuse composition. So as I mentioned, more filtrable waste, so more organic may be present. The leachate quality will vary. Elapsed time based on the age of the waste, ambient temperature, available moisture, precipitation quantity, and leachate groundwater intrusion, moisture content of the waste. Okay. So this, based on this only we can estimate the leachate quantity. So we have lots of methods to estimate the leachate quantity after closure, and that is pre-closure and post-closure leachate generation rate in the landfill vary, and we can calculate by different methods. So why we need to calculate the quantity of the leachate? Based on that only we can design the leachate collection system, like leachate collection pipe, that spacing of the leachate collection tanks, and then design of on-site treatment facility. So that is again a wastewater. So we need to design a wastewater treatment plant, that is called leachate treatment plant we need to design. Okay, so that's the pre-closure generation rate. So pre-closure generation rate may be based on the LV is the leachate quantity based on how much precipitation, how much moisture that is already present, minus evapotranspiration, minus volume lost. That is lost through absorption in the wastewater. Waste may absorb. If it is the dry waste, whatever the rainwater enters, it may be absorbed by the solid waste, and only some part will go into the leachate. So that also we have to subtract. So P plus S minus E minus AW will be the leachate generated quantity, that is pre-closure generation rate. After closure, we have lots of method to calculate. After closure, we can say only rainwater that is infiltrated or the cost for leachate generation. So we have water balance method, computer modeling, empirical equation, mathematical modeling, direct infiltration method, but usually we will follow water balance method. Okay, that's what I am going to discuss. Precipitation minus evapotranspiration minus runoff minus del S, that is a moisture that is already present, volume of soil and waste moisture storage. Okay. So this formula you can please remember, that is very useful for you can see one method called help software, or what we can say, it's a model, help model we will say. This help model will be used to evaluate the leachate quantity from the landfills. So that model uses this water balance method formula in its calculation. So we need to give all the meteorological conditions like how much rainfall, how much wind velocity, solar radiation to calculate evapotranspiration, and all the meteorological condition we have to give as the input to the model. It will calculate how much leaches is generated. Okay. So what is the characteristics of the leachate? So as I mentioned, pH will be around 3.7 to 8.9. You see high variation. It may be acidic or it may be alkaline based on the age of the waste. So if it is, as we mentioned in the 5 phases of the landfill gas generation and leachate generation, center phase, that is the third phase, will be having volatile acid accumulation. That time pH will be very less, but at the end pH will be very stable, around 7 to 8, neutral pH. Okay, electrical conductivity will also vary a lot. Fresh leachate will have lots of conductivity. Legacy, I mean old waste will have less conductivity. BOD will also be very higher. COD will be very higher. So that's what leachate treatment is. We are finding the conventional treatment plant is not suitable for leachate treatment. That's why lots of advanced tertiary treatment methods are required for leachate treatment. Okay, then iron will be there, potassium, magnesium will be there, then lots of ammonia, this type of metals will be present in the harmful heavy metals like lead, chromium, zinc, aluminum will be present in leachate. So you can see in the picture itself how much dark liquid it will be. Okay, then leachate collection design system we are going to design. So leachate collection system will have so leachate collection system will have 5 important components. One is main drain, that is the main pipe that is going going through which the leachate will be collected. Then side drains. Side drains will be like this. It's like a tree only. So I am showing you the top view of the landfill. So this is the landfill area. So below the solid waste, we are having the main pipe and then side pipes and then perimeter drain. Perimeter drain is like small drains we'll have. That is the perimeter drain. In all the sides we have the perimeter drain. Okay, to avoid the leachate percolation into the groundwater. Then drains and the protective layers. Around the pipes we have some protective covers and then leachate well. So the main pipe will collect the leachate and it will be stored in the leachate well. Okay, so that will be collected and it sent to the treatment plant. Leachate treatment system we have to this is leachate collection system and then leachate treatment system we need. So from the top view I am showing you. Then leachate problems. So the leachate may have some solids, it may clog, and then growth of microorganism will be there because it's have lots of microorganism from the solid waste. And then precipitation of minerals due to lower pH and higher pH, it will enhance the precipitation of some of the minerals in the pipe itself. It will clog. So when the pipe is clogged, there is no more leachate collection in the collection well, and then the pipe may become weakened by chemical attack due to acids. The pipe material should be chosen. We should not be susceptible to chemical attacks by the acid and solvents or oxidizing agents. Okay, so we need a proper barrier layer for the leachate collection system. Drainage layer. A drainage layer will have a high permeable gravity because whatever we are having, this main pipe should have a gravel and all that will allow the leachate to flow from the solid waste. Then nearby we have to have a fine soil, so that will filter the microorganism and silt and mud present in the leachate, and only the filtered leachate will enter into the main pipe. So that we need to have a drainage layer and then filter layer that is having granular and synthetic material to reduce the migration of fines. So drainage layer should have high permeability, filter layer should reduce, it should have a low permeable thing, and then slope we need minimum 2% of the slope, then only the collected leachate will enter into the drainage well. So proper slope should be maintained. Then French drain and tiles, these are all drain layers like made up of soil having UC maximum this and all you have to check. Then fine soil and refuse will have a minimum permeability of around 10 power minus 4 centimeter per second and a thick layer of cushion, because whatever the pipe we have should have a cushion, otherwise it will break. So this type of cushion layer with the engineered system against damage and attack for the filter. So you can see here the pipe before this is the starting construction phase for the landfill. So they are making the liner system. They are liner is the geomembrane. So they are placing the geomembrane around the landfill site. Then with a compacted clay liner at the bottom, above that geomembrane layer, then all the pipes will be there here. That's a collection system, and then soil. above that we are going to place the solid waste. Okay, so these are the system we can see here. So this is the granules useful for the proper migration of leachate into the leachate collection well. You can see the tile drain, French drain. So that will drain the, this refuse is the solid waste, and we have native material, that is underground soil, then low permeable liner, that is compacted clay and geomembrane liner. Above the drainage layer with the proper cushion. These are all what we say like gravels, and then fine layers, and then a drain pipe. Okay, so it will enter through the gravel, through the fine layer filtered, and it will enter to the pipe. So the pipe will be longitudinal, it will be collected into the leachate collection well. So the permeability of the drainage layer will be very less, and then drainage layer gravel should be washed to remove fines. Then this is called a French drain, used in the event of pipe failure or clogging. Additional contamination leak detection system should be there. Okay. And this is the clean out system. Whenever there is a clog, accessible manhole should be there to clean out the system. Now this is the top view for stormwater management. So around the periphery of the landfill, we need to have a periphery drains. It will avoid the rainwater runoff, that is the stormwater entering into the landfill. It will be avoided and will be collected through the periphery drains. Okay. Then leachate ponds or the lagoons. So after collection of leachate, it will be sent to the leachate ponds or lagoons. So with the proper aeration system, it will be evaporated or it will be treated with the proper aeration. You can see some of the bubbles coming out of the leachate, that is with the proper aeration system. We are keeping some air blowers at the bottom. It will pump the air into the leachate, so which will oxidize the organic matter present in the leachate. So it will be treated and it will be sent for some irrigation or some of the municipal solid waste, sewage treatment plant, normal STPs. Okay, so a double layer liner is required here. Same like landfill, for the pond and lagoon also we need to have a double layer a liner, so that the collected leachate will not percolate into the groundwater, and a barrier liner with leak detectors, and then the aerators are provided to reduce the odor issue. These are the leachate storage tank. If you are going to construct a leachate treatment facility, we can store it in a leachate storage tank. Okay, will remain open to the atmosphere. Otherwise, it will due to anaerobic digestion and methane production, it will burst. So leachate control, the best way to control is strict stormwater and runoff, proper segregation of wet and dry waste. Whenever the wet waste is coming into the landfill, leachate will be produced. And then aerobic landfill technology, that's what we are going to discuss in the coming slides. So landfill is always anaerobic because we have contained system. We are covering with the liner final cover. So there is no entry of oxygen into the waste, solid waste. So we had seen in the system also, oxygen got reduced in the first phase itself, methane got generated. So oxygen, whatever the oxygen present inside will be reduced. There is no more oxygen, addition of oxygen. But aerobic landfill technology is used as a latest technology that will avoid that will enhance the degradation process. That's what we are going to discuss. Okay. Yeah. Then landfill liner design. It may be geotextile, geonet, geomembrane, or clay liners. That is natural clay with compaction. It can be used. Okay. Then treatment technology. So we can use reverse osmosis. As you all know, RO system. RO system can also be used to treat the leachate. But clogging, because it's having a lots of solids. So membrane fouling will be often. It may happen. Often it may happen. So in many cases, the separation of ammonia is poor in RO itself, and the chemical adjustment to chemical addition to adjust pH and the two-step RO may be required. So first stage it will be treated, and then second stage RO, then purified water will be there. Then flocculation and precipitation, same like sewage treatment or water treatment. We are adding coagulant, so that will be precipitate, that will flocculate the organic matter, and then it will be settled. Coagulants and finer organic matter will be coagulated, and then it will be settled. and it is not, in spite of being cheap, this technology is not frequently used because of the addition of chlorine and sulfates. And then evaporation, it's very cheap method because in the lagoon and the pond itself, we are allowing the leachate to evaporate and it will be dried. So only the sludge we can collect and it can be treated in a sludge treatment methods. Okay, so and then the condensate vapor containing the volatile, whatever the evaporate gas will have more volatile components, harmful components. So the nearby residents may get health issues. So that should be avoided. It may have some chlorinated organics and ammonia. Then aerated lagoons. As I mentioned, in the pond itself, if you add some blowers, so it will be aerated and then all the organic will be aerobically degraded. So we should have a proper retention time. If the retention time is very long, then the nitrogen reducing bacteria may also, oxidizing bacteria may also develop. After carbon BOD, nitrogen BOD may also get reduced. And then maintenance and operation cost of this treatment method is also very low. And most of the landfill site, they are using aerated lagoons only. Then, as we know, activated sludge process, this may be used in many regions, similar to sewage treatment methods, aeration technique only. Normal aeration followed by clarification. So, if you are a civil engineer or environment engineer, you know what is ASP, activated sludge process. So, if you are giving lots, huge generation time, then it will be very suitable. Then RBC, rotating biological contractors. This is again a sewage treatment method. So there will be a rotator. It will rotate into the half of the tank was filled with the leachate. So once the rotator enters into the leachate and if it is coming out, then the microbes present in the rotator may get oxygen when it is coming out. Then again it will go to the leachate, it will degrade the organic, it will come out. So always it is rotating. So it's aerating and rotating. Okay, but here it is a fixed tank. So we are providing oxygen through outside, but here the oxygen was captured by the microorganism whenever the RBC is rotating. Okay, again trickling filter, as you know, it's attached growth aerobic system only. Then anaerobic biological treatment systems like upflow anaerobic filters, USAB, and most of the treatment technologies we can integrate. Most of the biological treatment like absorption, advanced oxidation treatment processes, and evaporation drying, that is the reverse osmosis technique, and combination of all this, that's called the integrated treatment system we can use, and then effluent can be left out. Okay. So the main consideration is low demand of energy, low demand of resources, low generation of residue, low environment impact, economically feasible, efficient operation, limiting concentrations. So these are all the aspects we need to think about. I think before choosing the proper leachate treatment system. So we have lots of treatment technology as we have discussed, but which is suitable for which type of leachate? We have to check the quantity and the quality of the leachate. We can assess the quantity based on health method or water balance method, and then we can assess the quality of the leachate. We can collect and test the quality of the leachate. So based on that, we can choose the proper treatment facility for the leachate, which should have less demand of energy and cost effective. Okay, these are the main consideration you have to have. Like moving bed bioreactors or advanced treatment methods, membrane bioreactors. These two are very important, MBBR and MBR. These are advanced wastewater treatment technologies. This is the current practice in the landfill technology, that is called bioreactor landfill. What I have mentioned as aerated landfills. So whatever the leachate I am getting, that will be recirculated into the landfill. Instead of treating, we are again recirculating the same wastewater into the landfills. That is called bioreactor landfills. And also I am injecting air through air blowers. So air injection system is there, and then liquid storage and the recirculation system is also there. So both will enhance the degradation process of organic matter present in the landfill. This is again kind of aerobic and combined anaerobic treatment technology only, because we are supplying air, the anaerobic degradation becomes aerobic, and then we are providing some moisture required for the treatment degradation. Okay, again bioreactor landfills are two types. One is aerobic. Both leachate and the air is circulated, then it is called aerobic, which enhance the aerobic activity. Once only the leachate is circulated and gas is not circulated, I mean gas is only collected but aeration is not there, then it's called anaerobic. Okay, only moisture is added, absence of oxygen, again it will be anaerobic system, landfill gas will be produced. But here it is aerobic, so there is no problem of air, what is called landfill gas. But here anaerobic, so gas collection system is required to collect the biogas. Okay. Then hybrid technology also we can have both aerobic and anaerobic, because top layer we can supply air, bottom layer can only circulate with leachate. So top layer will be aerobic, bottom layer will be anaerobic. This will also enhance the, because top layer will be always with the fresh waste, so it requires oxygen for degradation. So this is a hybrid technology. Okay, these are the unique features of bioreactors that simulate the natural biodegradation process, because we are supplying air and supplement leachate as a source of moisture. So moisture content is the single most important factor for to accelerate the decomposition. So that moisture we are providing through leachate. Okay, so approximately 35 to 65% of moisture will be present, always present in the landfill when we are recirculating the leachate. So this landfill gas production will also be reduced if you are following aerobic condition. But anaerobic unit, if you are following, then the landfill gas will be produced at the earlier stage itself. It won't require another 20 years to produce more full landfill gas. So within next 5 years itself, all the gas will be produced. It may be utilized. Okay, so main component is only when the inerts are disposed in the landfill, leachate, the toxic leachate may be may be avoided. The leachate may be not non-toxic, but and also the gas production will also be lesser. Whenever the organic is entering into the landfill, landfill gas will be more, leachate will be toxic. Okay, so this is the main point we are we have discussed here. So this is all about landfill design and leachate collection system and treatment technologies. So if you have any doubt in this, please unmute and you can ask, or you can post it in the chat box. We will move on to the old assignment discussion. I'll wait for 1 minute. If you have any question, please ask, unmute and you can ask, or you can post it in the chat box. So this is the 9th week. We have discussed about the disposal, that is the final functional element of solid waste. In this, we have discussed about the landfill, landfill types, landfill design, landfill site selection, then leachate. Two problem. One is landfill gas. The second one is leachate. So one problem we have discussed today: leachate collection and the treatment technologies. Okay, I will move on to the problem solving session. Please post the answer in the chat box. I'll show the question. I'll read the question and the options. Selection of best ranked sites of landfill is done based on selection of best ranked sites. Yeah. This is the first question of assignment old assignment solving. So selection of best ranked sites of the landfill is done based on pollution load index, Solvita index, site sensitivity index, bioaccumulation index. So we have discussed about 6 steps for landfill site selection. In that, best site selection is based on one index. That is, please post the answers in the chat box. Options also explain A, B, C, D. Yeah. So the answer is site sensitivity index. That's what we have discussed in the selection of best ranked site column. So the selection of most appropriate sites is based on site sensitivity index. That's given in the guideline of CPCB 2003. So based on the defined criteria, what we have discussed in the criteria for landfill selection, we can give some index, that is site sensitivity index. Okay. Okay. So the second question is monitoring of landfill should be done dash years after site closure. So we have discussed about the landfill life design life. So it has 3 components. One is active period, post pre and post closure period. So they are asking about So they are asking about the post-closure period. 20 to 25 years, 10 to 20 years, 15 to 20 years, 25 to 30 years. That is the monitoring period. So monitoring period will be 15 to 20 years. So 20 to 25 years will be the active period. After that, we need 15 to 20 years as a monitoring period. Okay. That's what we have discussed in the design life. Active period, closure and post-closure period. Active period will be 20 to 25 years. Closure and post-closure period will be around next 15 years. That's called the monitoring period. Okay, this is a multiple choice question. What are the factors that influence the leachate quality? Leachate quality they are asking. Groundwater intrusion, precipitation, ambient temperature, none of this. We can change the question as leachate quantity. So, okay. Factors that influence the leachate quantity. Groundwater intrusion, precipitation, ambient temperature, none of this. Okay, sorry. They asked about quality only. Okay, correct. So, quality and quantity is based on groundwater intrusion, precipitation, ambient temperature. That's what he was given in this. Groundwater intrusion, precipitation, and ambient temperature affects the chemical reaction and bacterial growth. So, that will affect the leachate quality. Again, a multiple choice question. What type of waste is suitable for sanitary landfilling? So we have two type of landfill. One is sanitary landfill, another one is secured landfill. So which can be suitable for sanitary landfill and which can be suitable for secured landfills? So commingled waste, that is the mixed waste which cannot be treated with any other treatment facility, can be suitable for sanitary landfill. Non-biodegradable waste, that is good, and then non-hazardous waste, and then inert waste. Okay, all the four are correct. I have to choose the first. Okay, this. Sorry for this. I have to choose this also. So commingled waste is one of the thing that is suitable. So commingled waste, non-biodegradable, inert waste, and non-hazardous waste. All are suitable for sanitary landfill. Which is suitable for secured landfill? Hazardous waste. Okay. Okay. Then fifth question. Then the fifth question. What are the problem associated with the leachate collection system? Problem associated with the leachate collection system. Optimum flow rate of leachate in the outlet, growth of microorganism in the pipes, chemical reaction in the pipe, clogging. We don't require flow rate and all because leachate may be produced anytime, any quantity will be there. So we don't require the flow rate and all like sewage treatment plant. But the growth of microorganism in the pipe is the problem, and the chemical reaction in the pipe is the problem because it may provide, it may create incrustation in the pipe, and precipitation will be there, and then clogging. So B, C, D will be correct. So these are the things we have discussed. Leachate problem, clogging with the silt and mud, growth of microorganism in the pipe, precipitation of mineral in the pipe, that is due to chemical reaction, and then pipe become weak due to chemical attacks. The flow rate is not an important factor or a problem. Okay, sixth question. Which of the component of the leachate collection system is used to drain the liquid to the collector drain pipes? Which of the component of the leachate collection system is used to drain the liquid to the collection drain pipes? Fine soil, slope, drainage layer, French drains. So collector drain pipe is the main pipe. If you see, so this is the main pipe we have discussed. That is the collector drain pipe. So in that or you can see this is the top view. If you see the section view, so this is having the ground level and then liner system and then cushion layer. In that cushion layer, the pipe will be embedded with a French drain system. Will be having fine layer, which will allow the liquid into the pipe. So the answer is the drainage layer, which is used to drain the liquid to the collection drain pipe. You see here, so this is gravel drainage layer. So it will allow the liquid and then fine layer will filter and it will enter into the drain pipes. You see here drainage layer which drains the liquid to the collector drain pipe. Which of the component of the leachate collection system is used to protect against the damage? Fine soil, slope, drainage layer and the French drains. So as I mentioned, French drains, fine layers are the engineer system that protects the filter against damage, because whenever there is already drawn here, whenever the fine soil is not there, the leachate that is entering into the pipe with silt, it will clog the pipe. So it should protect the leachate collection system. For the protection of leachate collection system from damage, we need a fine soil. Okay, not the French drains, it's a fine soil. Okay. Then the minimum permeability of the drainage layer in leachate collection system is minimum permeability of the drainage layer in leachate collection system be around 10 power minus 1 centimeter per second, minus 2 centimeter per second, 10 power minus 3, 10 power minus 4, 10 centimeter per second. So drainage layer will be around 10 power minus 3, but the bottom liner system will be around 10 power minus 12 compacted clay liner, 10 power minus 12 centimeter per second. That much very low permeability is required for liner system. But drainage system, we should allow the leachate, so 10 power minus 3. So that's the drainage layer. 10 power minus 3 is the permeability. Fine soil 10 power minus 4. It should allow the leachate, but it should filter the leachate. So 10 power minus 4. Okay. And what are the location restriction that may be considered for landfill site? 400 meter away from highways is wrong because 500 meter. 500 meter away from public park is okay. 100 meter away from pond, 500 meter away from water supply is also correct. So what are the answer? I'll check on. Public park is around 1 second. I will go to the presentation and check the. Public park 300 meters, sorry, not 500 meter. So the answer is public park is 300 meter, highway is 500 meter. From the pond and the lake, it should be 200 meter. And water supply 500 meter is correct. Okay. So what are the ways of controlling leachate in the landfill? Controlling the leachate: restrict runoff water, aerobic landfill technique, use of heterogeneous waste, use of proper liner system. So to control the leachate quantity, we need to restrict runoff water, and then aerobic landfill technique, use of proper liner system will control the leachate in the landfills. Okay, so that's what we have discussed here. Strict storm water and runoff, it should be controlled. Proper segregation of the wet waste and dry waste. Aerobic landfill technology, use of proper liner system will restrict the storm and runoff water. Okay, these are the leachate control systems, the avoiding system instead of collection and treatment. Again, and the location restriction for the landfill site be around 500 meter from the water supply. It is very important. Water supply in the sense water supply wells or the surface water body, it should be 500 meter away. Secured landfill is to dispose. As I mentioned, two type of landfill. Sanitary landfill is for four other suitable waste, and then secured landfill is for hazardous waste. Okay. Then that's what mentioned here. Sanitary landfill is for municipal solid waste. Secured landfill is for hazardous waste. Active period of sanitary landfills. So landfill design life will be active period, closure and post closure period. Active period will be around 20 to 25 years. Post closure period will be around 15 to 20 years. Okay. So that's what we have discussed. 20 to 25 years will be active, 15 years will be closure and post closure period. So totally is the design life of the landfill. What is the type of waste suitable for sanitary landfill? So non-biodegradable, non-hazardous, inerts, and commingled waste. All the above. Okay. Then, which component of landfill prevent disease-carrying vector from entering into the landfill? So, which is important? Lift. Height is not the correct option. Daily cover. Cell. Cell is the waste storage area. So that won't protect. Daily cover is the cover area for the cell with some soil or any locally available material. And then final lift is also height. So daily cover is the one which will protect the solid waste in the cell, and it will protect from disease causing vectors. So it won't enter into the solid waste and it won't create any problem. Cell is daily cover is the answer. Okay. Okay. Then which type of landfilling method? So we have discussed about three principles of landfilling methods can be used when the groundwater table is higher. So this is the ground. The groundwater table is very high, near to the ground. So if you dig 1 meter also, you will get water. So at this area, which method of landfilling we can use? Trench method, or excavation method, area method, or canyon method. So when the water table is very high, we have to go with the area method, above ground method. The water table is very low, we can use trench or excavation method, or hybrid also you can use both. Okay. Canyon method is only with the hill regions. We have to check the water table throughout the year. If the dry period or summer seasons, if the water table is very low, we should not use excavate method, because during monsoon it may reach here and it will contaminate the waste. Okay. So area method is suitable when the water table is very high. This was the three method: excavated trench, area, and canyon depression method. So what is the main gas responsible for landfill fire? So landfill gas is one of the reason for landfill fire. So landfill gas contains methane, carbon dioxide, but methane is highly flammable. Okay. So methane is the gas responsible for the landfill fire. So Kodungur garbage burning, you can see in Trichy also, we often get the landfill fires. So because of most of the waste is legacy waste containing combustibles, and the methane may be there inside the waste. So while digging the waste also, you can see some of the fumes like this. That is due to accumulated heat. Then selection of best ranked sites of the landfill is done based on. So this we have already discussed, the site sensitivity index. That's the site sensitivity index to choose the best ranked sites. Okay, that's all about today's problem solving session. So if you have any doubt in landfill design and leachate collection system design, you please unmute and you can ask, or you can post it in the chat box. If you don't have any question, you can leave the meet. Thank you so much for joining today's session. We are in the 9th week of the session. Thank you so much. I'll be there in the meet for next 2 minutes. Okay. So if you don't have any question, I will end the meet. Thank you so much for joining. tomorrow is the deadline for assignment for week 9. Please do the assignment before the deadline if you are opting for exam and certificate. Thank you so much. I'll end the meet.